While you sleep, a competition is unfolding at 7.8 kilometers per second. Forget tanks, forget aircraft carriers. The next great conflict may be decided in low Earth orbit. If a nation loses control of the ultimate high ground, global navigation could fail. Financial networks could desynchronize. Military forces could go blind. Our entire terrestrial civilization could go dark instantly. The end of the sanctuary. For much of the 20th century, space was treated as a scientific sanctuary. The launch of Sputnik 1 in 1957 initiated the space age, but it was framed as technological competition rather than open militarization. Later, agreements like the Outer Space Treaty sought to prevent the placement of weapons of mass destruction in orbit. Space was seen as neutral territory. That assumption no longer holds. In 2026, low Earth orbit, commonly abbreviated as LEO, is an operational military domain. Nations deploy satellites not only for communication and reconnaissance, but for resilience, maneuver, and potential engagement. The sanctuary is over. Why low Earth orbit matters. Low Earth orbit spans roughly 160 to 2,000 kilometers above Earth. It is the most strategically valuable orbital band for 3 reasons. Latency. Signals travel faster between LEO and ground stations compared to higher orbits. Imaging resolution. Reconnaissance satellites achieve superior spatial resolution. Launch accessibility. It is cheaper and easier to reach than geostationary orbit. Modern civilization depends on this region. Navigation systems such as United States Space Force-operated GPS satellites enable precision agriculture, aviation routing, ride-sharing logistics, and missile guidance. Communication constellations like SpaceX's Starlink provide broadband connectivity across conflict zones and remote regions. Every global stock exchange relies on nanosecond-level time synchronization derived from space-based atomic clocks. Remove orbital infrastructure, and the cascading effects would be systemic. The physics of orbital warfare. War in space is governed not just by strategy, but by orbital mechanics. Objects in LEO travel at approximately 28,000 kilometers per hour. At these velocities, even small fragments become hypervelocity projectiles. Intercepting a satellite requires precise tracking, predictive modeling of orbital paths, kinetic kill vehicles or co-orbital systems, extreme delta-V efficiency. In 2007, China demonstrated a direct descent anti-satellite missile test, creating thousands of debris fragments. In 2021, Russia conducted a similar destructive test, generating international concern over space sustainability. These events highlighted a dangerous reality. Destroying one satellite can contaminate orbital lanes for decades. This is not conventional warfare. This is physics-driven deterrence. From surveillance to bodyguard satellites. Historically, satellites were passive observers. Today, nations are developing proximity operations satellites, spacecraft capable of maneuvering near other objects. Officially, they are labeled as inspection or servicing platforms. Technically, they possess dual-use capability. The psychological shift is profound. Instead of assuming immunity, states now deploy bodyguard satellites, escort systems designed to monitor, shield, or potentially disable hostile spacecraft. This mirrors naval doctrine. Aircraft carriers are escorted by destroyers. In orbit, critical satellites may soon travel with guardians. Directed energy and non-kinetic threats. Not all anti-satellite systems rely on explosive impact. Directed energy systems, such as ground-based lasers, can dazzle or blind optical sensors without creating debris. Cyber operations can infiltrate command links. Electronic warfare can jam satellite communications. The objective is not always destruction. Sometimes it is denial. Control of data flow may matter more than hardware survival. The Kessler Syndrome risk. Physicist Donald Kessler proposed a scenario in which cascading collisions generate exponential debris growth, rendering certain orbital regions unusable. If major powers engage in kinetic exchanges in LEO, the resulting debris field could disable commercial satellites, block future launches, trigger insurance collapses in the space industry, disrupt global internet coverage. In effect, orbital conflict could harm the attacker as much as the defender. Mutually assured disruption becomes the new deterrence model. Strategic superiority and the ultimate high ground. Military theorists have long argued that controlling elevation confers dominance. In orbital terms, the advantage is absolute. Satellites provide missile early warning, battlefield intelligence, secure communication, precision navigation, nuclear command and control, redundancy. Without space assets, modern militaries revert decades in capability. The creation of dedicated space commands, including the United States Space Force, formalized what strategists already understood. Space is now a warfighting domain. China, Russia, India, and NATO members are investing heavily in counterspace technologies. No major power is ignoring LEO. The blurred line between civilian and military. One of the most destabilizing factors is dual-use infrastructure. A commercial broadband constellation can support civilian education or provide battlefield connectivity. A weather satellite can assist disaster relief or military logistics planning. When civilian and military roles converge, escalation risks multiply. If a commercial satellite aids a military operation, does it become a lawful target? International law has not fully resolved this dilemma. Real-world consequences for civilians. This is not abstract strategy. If LEO assets fail, ATM networks lose synchronization. Aviation navigation degrades. Emergency services lose satellite communication backups. Shipping routes become less precise. Financial markets desynchronize, triggering systemic risk. Space warfare is terrestrial warfare by proxy. The battlefield may be silent, but the consequences would be immediate and visible on Earth. The governance challenge. Existing treaties prohibit weapons of mass destruction in orbit, but they do not explicitly ban anti-satellite systems or proximity operations. Efforts to establish norms, such as debris mitigation guidelines, remain voluntary. The challenge is structural. Verification in space is complex. Dual-use technologies are indistinguishable from weapons. Strategic mistrust discourages transparency. Space governance now resembles early nuclear arms control. High stakes, low trust, incomplete rules.
Don't forget to like and subscribe to New Informative for more trusted tech and